Hello everyone, welcome to the presentation. My name is Sanjay Pujare. I am in engineering at DataTorrent, and this webinar is about our AppHub, which I'm going to talk about, and how the AppHub eases application, big data application development, deployment, and operating these applications. So let me make it a full screen. Okay. So the goal of the AppHub that I'm going to talk about is to reduce time to market and speed up application development and deployment and facilitate operationalizing these applications. I'll talk about the vision that DataTorrent has. The vision can be described at a high level as productizing big data. Now, currently, big data is neither productized nor operationalized. And what I mean by that is you have a set of technologies like Hadoop and MapReduce and all that stuff, but these technologies are just there for people to use. But these technologies cannot be so easily used by businesses because ultimately what businesses want are reliability, operability, and repeatability, and of course the most important is reliability. In the process, businesses also want to reduce the cost of ownership and cost of operating these applications, big data applications. So the cost of ownership consists of three factors. One is time to develop, then time to deploy, which means even after you have developed your application, you need to test it, you need to stage it, you need to test it with sample data and all that stuff before you can put it in production for your business operations. So that is the second aspect. And the third is ongoing operations and how easy it is for you or for the business to operate your big data application. So what DataTorrent wants to do is to help their customers with the total cost of ownership by helping them in all three areas, as we'll see. So the DataTorrent has already a set of products that allow users to build applications and deploy them. The focus is on building applications using simple interfaces. And recently, on top of these tools, what DataTorrent decided to do is create this thing called AppHub, which is a set of pre-built apps. The applications, we call them templates. They are based on a set of patterns, repeatable patterns that we commonly see among our customers. So we basically want to leverage code reuse in these templates. So we have, let's say, one template that can be deployed across multiple use cases and possibly in different industry verticals. By the way, there is one thing I wanted to say. If you have any questions, feel free to put your questions in the questions tab in your GoToMeeting client. And every few minutes, I'm going to look at your look at the questions tab to see if there are any questions. So far, none. So let me go back to my presentation. Anyway. So I was talking about reducing the total cost of ownership, and in the process, what DataTorrent did is to create this AppHub, which consists of a set of templates based on repeatable use cases. So what DataTorrent does is it develops these templates, tests them, and makes it easy to deploy them. So as we'll see, you have these templates available. There is a set of documentation plus videos that go along with the templates that allow you to understand what the template is doing and start using it. The third aspect of DataTorrent offering is management and visualization. So that was there even before we developed this AppHub. What we have is a console or a management console that allows you to take these streaming apps and deploy them and monitor them on an ongoing basis, and also visualize various aspects of the app, such as metrics and events and all that stuff, as we'll see. So what is this next generation big data architecture is? What is it that DataTorrent is trying to do? We need to see what is underneath the set of applications, big data applications that we are talking about. So typically these applications are long running or they're continuously running. They deal with unbounded and continuous data streams. The applications also have to deal with a variety of data sources, such as message buses like Kafka, or files in a file system, including HDFS, or various real-time data sources such as IoT or social media, which are continuously generating events which can be captured either through APIs or some other mechanism, right? So so that is on the source side. The applications also have to deal with putting out data or writing out data on various data destinations, including databases or message buses like Kafka or file systems like HDFS. And it has to do all this with very low latency and with real-time processing. And it'll also be beneficial to be able to visualize the various aspects of the processing, such as metrics related to the application, and management of the application, like maintaining application uptime and all those things. One other aspect of the big data applications or the big data platform is how to improve latency by doing in-memory processing. Now, if you can have a big data platform that allows or that supports in-memory processing, because in the process of processing the incoming data, if you have to save and read data from disk or even flash storage, it is going to be thousands or even million times slower than doing it in memory, right? If you look at the access times of primary memory versus even SSD, there is a factor of 1,000 to million times difference. So doing in-memory processing will really give you the low latencies that we are looking for in our big data platform. The fourth aspect is, it's not enough to process the incoming data in a stateless manner, but we also want to be able to do stateful processing, such as aggregations. For example, if the incoming data has counts or numbers, we want to maintain averages and sums and all that stuff. And we also want to do dimension aggregation. So for example, for various users, tell me, for how long a certain user was active on a website and stuff like that. One other aspect also is rule-based processing. So I want to be able to apply rules to my data that is flowing through my pipeline, so that I should be able to do things like anomaly detection or fraud detection and stuff like that. The other aspect I wanted to mention is batch support. For a platform that supports continuous streams, it is not too difficult to also do batch processing. Now, batch processing is typically For example, a set of files are dropped once a day in a certain directory, and your batch program needs to come up either at a fixed time or based on some trigger. Say a trigger that says that the files have been dropped in the directory, and then the batch program needs to wake up or start and process those files, do all of its big data processing, generate the output, and just quietly shut down. So that support is also something that is offered by our platform, as we'll see. Now, I have a simple example at the bottom of the slide, which illustrates all of these things. So this use case is for a web server. So let's say a social media site, which is a web service. A lot of users are visiting that site, and the web service is generating a lot of logs. The logs basically, once processed, can give you insight into users' activity on the social media site. So these logs are generated by the web service. The logs or the events in the logs are ingested into a Kafka message broker. The rest of the diagram shows what the Apex application or the DataTorrent application does. There is a Kafka input operator or Kafka connector that reads the events from the Kafka broker. In case those events are compressed, the downstream pipeline will decompress these events, parse them, and do some amount of filtering, and will pass on that data to its downstream operators, which is doing dimensions compute or dimensions aggregation. So at this in this operator, what it will do is, based on various dimensions such as users or geographical locations or sessions, it will be able to generate various aggregate information as the amount of, for example, the amount of time a user has spent at the website, and the number of times a user has visited a page, or the number of chat interactions between different users. All of this aggregate information can be computed by the dimension aggregate stage. Finally, it generates output that is fed into an output store, such as Kafka in this case. So at this point, Kafka itself can be used by other downstream processes, such as, let's say, a visualization application based on Tableau, which will enable the user to visualize various aggregate information that has been computed by the Apex application, that gives the user insight, real-time insight into the activities that have been going on the web service. So this is I hope that kind of illustrates where our platform and where the applications are used. Now, so I talked about a typical application, but let me explain the ecosystem now. In this slide, you can see the ecosystem. Let me start from the left. In the meantime, let me see if there are any questions. No questions so far. So going back to the slide. Anyway, so in this slide on the extreme left, I talked about the data sources, the typical data sources that are the inputs for a big data application. So things like app servers or web servers or social media or sensor data in case of IoT, which generate a lot of events. These events are, they have to be kind of made available to a big data application, such as a DataTorrent application, through what is called the plumbing, which is a set of layers such as Kafka or RabbitMQ, basically what I call message services or message buses, which accept input from these data sources and make them available to the DataTorrent ecosystem. So to the right of these message buses or message brokers, we have the DataTorrent box. The DataTorrent box starting from the bottom, has Hadoop, which has both Yarn and HDFS. So on top of Hadoop, we have this layer called Apex. Let me give you some background of Apex. So DataTorrent developed Apex back in starting in 2012, and in 2015 we open sourced Apex. Apex consists of two parts. One is the Apex core, which is the engine for running streaming applications. And the other part of Apex is Malhar, which is the layer at the top in this box in the middle, the blue box. You see these three circles, Oper 1, Oper 2, Oper 3. That is basically Malhar, which is a set of operators, or you could say a library of operators, which are required for developing any Apex application. So what is an operator? An operator is a processing unit, the smallest unit of processing that is used in an Apex application. There are three kinds of operators. There are input operators, which talk to an external system, such as, let's say, a Kafka message broker. Then there are output operators, which talk to external systems like a database, Oracle database, or again a Kafka broker. The output operator sends data out to these data destinations. And then the third kind of operators are processing operators, which have an input port and an output port. So a processing operator receives tuples. A tuple is basically a data record. The tuples are processed by the processing operator, and it generates a processed or an output tuple on its output port. So in summary, a processing operator has both an input port and an output port, because a processing operator is processing the input and generates output. An input operator has only an output port, because what the input operator does, it talks to an external system and receives data from it and generates output on its output port to be sent to a downstream operator, which typically is a processing operator or an output operator. And the third category is the output operator, which has only an input port, because it receives these tuples from upstream operators, and it basically writes these tuples out to an external system, such as an Oracle database or Kafka. So the Apex pipeline ends at an output operator. The tuples don't flow anymore downstream. They just go out to an output system. So that covers the slide, except there are two circles here, which is the real-time data visualization and real-time analytics. So what our platform does is, when an application is running in the whole ecosystem, we also allow our users to visualize various aspects of the application, including metrics and events. So metrics such as latencies and the amount of data and the amount of tuples that are flowing through the pipeline can be visualized. We also allow users to visualize application KPIs. So the application can define, using a feature called autometrics, these application-specific metrics in their operators or in their application, and the metrics for these application-defined counts are automatically made available to the visualization widget. I'm not going to cover that in detail here because we don't have much time, but that is this is the concept of autometrics and dashboards and widgets. You can look it up on the DataTorrent website. So that I have covered the ecosystem, DataTorrent ecosystem. This slide talks about our architecture in more detail, and basically in this slide, if you look at the the boxes inside this maroon outline, there are three kind of components. The blue layer is all Hadoop. DataTorrent platform runs on top of Hadoop. Typically the customer deploys his own Hadoop cluster, and we support all the major Hadoop distros, including MapR, Cloudera, and Hortonworks. That is the blue box. On top of Hadoop, we have Apache Apex core engine. Now, Apache Apex core engine is what does it do? It is the bottommost layer of a big data application that runs on top of Hadoop. It does things like fault tolerance. So, for example, if an operator or a container dies, then the engine is responsible to recover the state and restart that operator or container. The engine is also responsible for what is called dynamic scaling. So what it does is, this is interesting. So Apex supports dynamic partitioning. An operator can be partitioned. So typically what happens is when you deploy an application, the engine creates a plan, right? A logical plan. I'll show the logical plan later on when I demo the application, but a logical plan is just a DAG or a pipeline at logical level. The logical plan is then converted into a physical plan where the engine will create partitions, multiple partitions based on user input. And so, for example, an input operator can be partitioned to talk to the Kafka broker if the topic that it is going to talk to already has multiple partitions. And then if the application is configured to use parallel partition, then all the downstream operators of that input operators are also correspondingly partitioned, and we call that parallel partition. So anyway, once the partitions are created, if the user has so configured, the engine also supports dynamic partitioning, which means if the amount of data flowing through the pipeline is too much or has exceeded certain threshold, then the engine will partition the operators further to utilize the hardware to process the extra incoming data. So that is dynamic scaling, which is one of the important features of the Apex platform. The other thing, which is, of course, it needs to do is implement streams and the communication. So what happens is a streaming application is a distributed application that runs in the Hadoop cluster where tuples are flowing in the pipeline, and tuples need to flow from one container to another container through a pipe or a stream that is implemented by the Apex engine. And you can imagine that these streams can have multiple sources or multiple things, and then the platform implements this through what is called a buffer server. It's like a publish-subscribe mechanism where an operator, when it's sending out tuples to the downstream operator, will publish these tuples to the buffer server, and the downstream operator subscribe to the buffer server to receive these tuples. Anyway, so all of this stuff is part of the Apex core engine. The Apex core engine is also responsible for window and event management. Although this is a streaming system, the streams are split into windows, each of 50 milliseconds. The windows are mainly used for bookkeeping. So any state recovery or even metric calculation, all that happens at window boundaries. And the engine is responsible for keeping track of windows and events. So that is the Apex, the green box, which is called Apache Apex. On top of it, we have the Apex Malhar operator library, which is also part of the Apex layer that I talked about. These are operators, input, output, and processing operators. We have a variety of operators. By the way, all of this is open source, so you can go to the GitHub repository and look at the operators which are part of the Malhar library. We have operators for ingestion, enrichment, analysis, and alerting, or even outputting to various data destinations. One other thing that we have in Malhar is the high-level API, which is similar to the streaming concepts in Java 1.8. So you can actually, instead of writing low-level Java code, you can write code in using Java streams, provided you use the high-level API from Apex Malhar. And as I mentioned earlier, we also have batch support to trigger the start and stop of batches and various events related to batches. So this is these two layers are open source. They are part of Apache Apex. On top of it, we have the application templates, which is what this webinar is about. The application templates cover various use cases, as mentioned here: ingestion, replication, as well as anomaly detection, and anomaly detection using machine scoring or application of rules. I will go to the AppHub page and we'll see what kind of templates are there. On top of that, I mean, at an abstract level, you can see that these templates provide industry solutions. So, and a template plus an industry use case gives you what is called an industry solution. And so one way to look at the AppHub is that we provide industry solutions in various verticals, such as financial services or ad tech or customer 360, customer experience, or industrial IoT and stuff like that. So that is the topmost layer where we can look at the AppHub from industry solution point of view. Then on the right, these three vertical bars basically talk about the tools that cover all three or four layers, which is basically the ease of use that users want for managing and monitoring applications, for visualizing various aspects of their real-time applications, and also to rapidly develop and deploy the applications. So those are the tools that DataTorrent has developed and has made available for the last 2 years. I'll also show in my demo, I'll show the tool that I'm talking about, the management and monitoring tool. Okay, the next slide, app templates. So why app templates, right? So what is the motivation for app templates? What DataTorrent noticed, after having been in business for the last 3-4 years, a number of customers have licensed our technology. What we noticed is a set of repeatable patterns based on use cases that we see for big data applications. So these repeatable patterns that we see, we created app templates out of them. And that is the motivation for creating these app templates and making them available on in our AppHub. The goal of these app templates is to reduce time to market using these templates. Customers or prospects can use these templates as pre-built apps, and they can be the starting point for their ultimate productized application that they want to use in their business. As you'll see, you can just go to the AppHub. You can download and launch the template or the app. within a few minutes, you can see the template or the app working in your Hadoop cluster. Um, then we also make the source code of the template available. I'll show that too. So because the source code is available, if you are into Java development, you can easily customize the template to suit your logic or to your business logic, as I'll show in the demo. So we have made it easy to customize and also add logic or add operators in these app templates. If you look at, so earlier I talked about the repeatable patterns. What are these repeatable patterns that give us these app templates? So, the most common pattern we see is data movement, moving data from A to B, right? So some examples are like in disaster recovery, moving data from the production data lake to the backup data lake, right? So you typically, let's say, move from a database to HDFS as an example. The second one is ingestion from a streaming source into a data lake. So for example, take data from Kafka as your streaming source and write it out to HDFS. That is a second pattern. Another one similar is, if there are transactions which are being recorded in your SQL database, read those transactions and move them into archive data lake as your archive storage. Another interesting use case which we see, for which we also have app templates, is moving between cloud to on-premise or vice versa. So let's say you have some applications in the cloud and you want to move the data that got generated or saved in the cloud. You want to move the data to your on-premise data lake. That could be a big data application, or it could be vice versa. Maybe you have some on-premise processing going on. You want to move the output of the output data into a cloud. That could also be your big data application. As part in all of these, you could be also doing some kind of data preparation or data cleansing, such as dedupe or enrichment. So there are templates also have some of those operators as part of the templates. And one interesting stuff that we have noticed that we call shift left, which is so what I talked about is data movement or data ingestion, moving data from point A to point B with some amount of enrichment or a little bit of processing, such as cleansing and all. But what customers also want to do is to process and analyze this data in the pipeline in real time. So as the data is flowing through my pipeline, I also want to process it and analyze it for various things, such as machine scoring or fraud detection or anomaly detection. And I would like to do that in my pipeline instead of doing it after the fact, after the data has been saved in my data lake or in my data storage. So that is also something we see that customers want to do. So we have started to develop app templates for doing that. Okay. So in the meantime, let me go back and see if there are any questions. Nothing so far. So yeah, okay. So what is this AppHub that I've talked about? I have a screenshot here. We'll see the AppHub, the actual AppHub when I go to the not only the website but the RTS page. You'll see the screenshot. So the AppHub is present in both DataTorrent RTS as well as the DataTorrent corporate website. It's a central repository for the big data application templates that I've talked about. these templates are delivered through the AppHub. So a typical use case is if you're accessing the AppHub from your DataTorrent RTS, you just click the import button and the template is imported into your DataTorrent RTS. And over there, it is ready to use. The only thing you need to provide when you want to launch the app is configuration parameters, such as the Kafka message broker coordinates, or for HDFS, the output HDFS locations and all that stuff. The value, what DataTorrent has done is it has basically developed these app templates. It has tested them. So we have assured a minimum level of quality. And we have published these templates on the AppHub, which is maintained by DataTorrent. We have done this after identifying various use cases and coming up with this not abstract, but kind of common patterns which can be captured in our templates, right? So we are continuously creating more and more templates. What you see here are not the only templates, but we'll see more and more templates as we see more use cases, as we see more requests from our customers and from our users and prospects. What does AppHub give you? What do the templates give you, right? So the AppHub is a delivery mechanism, as I talked about. It's a delivery mechanism for delivering the app templates that DataTorrent has developed for the various use cases. What we also have done here is we have recently also focused on cloud integration. So as part of this whole vision, we have also developed AWS installer and kind of wrapped the app templates in the AWS installer. So if a user or if a prospect doesn't actually have an on-premise Hadoop cluster, all they need to do is get an AWS account and have EMR, provision EMR, and then all they need to do is use our AWS installer, which will automatically use or provision EMR into your AWS account. And on top of that EMR, it will also deploy the DataTorrent RTS components, and it will deploy the template into the DataTorrent RTS. And as the last step of the whole AWS installer process, you can actually see the template that is ready in the in your RTS instance in AWS, ready to be launched and ready to be used, provided you have the the runtime parameters available to be provided to your template. So that is one recent addition we have made to our AppHub offering. One other aspect, one other thing that I would like to brag about our templates is schema support. Now, what is schema support? So schema support is basically schema agnostic templates. So our templates don't assume or don't have hard-coded schemas in them, right? So what we have done is we have separated the logic or the code from the data or the schema which goes with the use case. So for example, if you want to take a template and use it, let's say in the healthcare space where they have a specific schema they want to use, then you can just use a template, a generic template, apply the schema that the user is going to use in the healthcare space, and use that template for that particular use case, right? You don't actually have to rewrite any Java code for using this generic template for a particular use case which has a particular schema, right? I'll touch upon that briefly when I demo a template, but that is the overall idea of schema support in our app templates. One other thing is, I think I mentioned it before, is the source code for all of our templates is available in GitHub, and it's Apache license. So you can just look at the source code, you can download it, you can modify it, you can customize the logic to suit your purpose, and you can actually, basically modify the template for your own use, and you can start using it. So that is the open source aspect. One other last thing that I wanted to mention is metrics and visualization. So what the DataTorrent RTS platform allows you to do is to visualize various metrics about the streaming application, such as the amount of data that is moving through the pipeline, the gigabytes of data that has moved, the number of files moved, or things like number of files per hour processed. So I'll in my demo I'll show you that the metrics visualization. So that is the value proposition behind AppHub. So what are the benefits? So benefits are ease of use. You can quickly import and launch these apps or the app templates in your DataTorrent RTS instance. You can easily customize using the source code, because we have made the source code available. So that covers the ease of use aspect. The second aspect is reducing the time to market and reducing TCO, total cost of operation. So the reduced TCO is offered by the DataTorrent RTS platform, as we'll see. The third aspect is during operations, we help the user visualize various operational metrics of their streaming application, such as the throughput, the latencies, and even some of the application-specific metrics, such as number of files processed or amount of data transferred, or any application KPIs that the user has defined in his application. So these are the benefits that one can obviously see in our app templates offering. Now, the next part of this session is the actual app template demo. So everything that I've talked about, I'm going to show you now. So let me get out of this presentation mode and go to my browser. This is where I have my DataTorrent RTS running. So this is the RTS console that I talked about. It has, you can see multiple tabs at the top. The ones that we are going to talk about are develop, where you actually manage the applications or the application packages that you are either importing from AppHub or that you have developed on your own. The second one is monitor, that shows the currently running applications in your Hadoop cluster. You can see various aspects of your running application, the metrics and all that stuff that I talked about. It visualizes the part that I talked about. I'm not going to cover that here because visualization needs its own session. I won't be doing justice to this aspect of by just talking about it for a few minutes. So I'm not going to cover it right now. But the main thing that I want to cover now is AppHub. So as I mentioned, the AppHub is a page in your DataTorrent RTS, which shows all the templates that are currently available. So there is a search field that, let's say I can type Kafka here, and it brings up a short list of all the templates that deal with Kafka, right? And let's say the other one is HDFS, and that also brings up a short list of all the templates that deal with HDFS. So the one that I'm going to demo right now is Kafka to HDFS Filter App. Let me click on this one. it takes me to a page which talks about the template. Now, what the template does, it shows a pipeline. The pipeline is, at the left-hand side is a Kafka input operator. I talked about operators in Apache Malhar. So there is an operator, a Kafka input operator that is talking to the Kafka message broker, receiving data. The data is fed to the next downstream operator, which is a CSV parser, which is going to parse the data. So each tuple from the Kafka message broker is a pipe delimited tuple, which has multiple columns. The CSV parser will convert that tuple into a PoJo. That PoJo will be sent to a filter operator. Now the filter operator, that is where the schema comes into picture. I talked about schema agnostic applications and operators. So what the filter operator does is it filters the tuples. So in this example, I'm going to filter the tuples based on certain column values. So the output of that operator is filtered so that I get only a subset of tuples that are received by the filter operator, right? Downstream of this is a formatter operator, which is the reverse of the parser, which takes the PoJo and then it generates a string tuple, which then is sent out to the file output. And this one is sent out to my HDFS file system. And that is what gives me the Kafka to HDFS filter app. I think there might be some questions here. Okay, maybe not. Okay, so this is the template as seen in the AppHub. What I'm going to do is I'm going to I have accessed this from my RTS. I'm going to click on import. This imports the template in my RTS. Give me a few seconds. As soon as it is imported, I have this pop-up here that shows me that the template has been successfully imported. This one is imported in my RTS. I can go back to my develop tab, click on application packages, and you can see that this one, if I select the right view, it shows this package. It was recently imported, last modified 19 seconds ago. So this is the package that is available for me to launch. As I'll show you later, you can also upload a package. So I'm going to customize this template and upload, but for now, let's just launch what we have. So I'm going to launch this app, but before I launch it, I'm going to show you what I have in my Kafka Broker. So I have the Kafka Broker running in my HDFS cluster. So in my Kafka, I have a list of topics, right? One of the topics is called transactions. If I use the Kafka console consumer, it will dump. It will show me what is there in this topic. The topic has a bunch of tuples. Each tuple is, like I mentioned, is a pipe separated set of columns. There are 3 columns in each tuple: a number, a string, an alphanumeric string. Typically the string is user underscore something, and the last one is a number, which we call an amount. And as I talked about the schema, in the schema that the application is going to use, the last column is defined as amount, right? So my app template is going to read these tuples and it's going to filter them. I'll show you what the filter does. But going back to my launch dialog box, I'm going to launch this app to read from the Kafka Broker that we just saw, and I'm going to use my cheat sheet to enter the broker information. So going back to this one, that is my Kafka Broker list. My topic name is transactions. Let me just make sure I have the right spelling, transactions. Then I'm also going to my output directory. This is the HDFS output directory. I'm going to say webinar 2, and my output file name is going to be default opt1 or output 1 is going to be my output file name in my HDFS directory TMP webinar 2. I also need to add some default properties. I need to, because I have already populated Kafka Broker with topic. I want to read from the earliest because I don't have data currently coming into my topic. So I'm just going to start reading from the earliest just to demonstrate this app. And the other thing that I talked about, which is the schema and the schema in connection with the filter operator. So the filter operator has been told about the schema of my input tuples. The last column that we saw is defined as amount. So I can define, in my filter operator, I can define a filter condition that says that filter the tuples for this condition where only if the amount is greater than 20,000, then allow the tuple to pass through, right? So going back to this, as you can see, my last column has numbers. Some of the numbers are more than 20,000, others are less than 20,000. So on the output side, we'll see only the tuples which are the last column more than 20,000 based on this condition. So let me just verify my input parameters. Everything looks okay. And just remember the output file name is default output 1. So I'm going to launch it. It takes a few seconds for RTS to package the application and send it to Hadoop, so that Jan will unpack it and find containers, deploy containers onto the nodes. And once that is done, as you can see here, then the operators inside those containers are started and the application starts running. Now, this is the visualization part that I was talking about. The application has started running. Over here, you can see the DAG. Above each operator and below each operator, you see a bunch of numbers. The top is total processed tuples, and below the bottom under each operator is the total emitted, right? So the input one obviously just emits, so it emits all these tuples. The second one is processing so many tuples and emitting so many. So the parser is just for every single input is generating an output. The filter one is interesting. Based on the filter condition, it is receiving almost like 1,000,000 tuples, but it is emitting on its output port only around 1/3 of them, or between 1/3 and around 30% of the tuples are being emitted. The filter operator, this is the filter output, which is the filtered stream. The formatter operator, which is downstream of the filter operator, is just formatting the PoJos into a string. Again, for every input tuple, there is an output tuple. So these two counts are the same. And the output, the last operator in my DAG is the file output, which is receiving all these tuples. And of course, it doesn't generate anything within the pipeline. It just writes out these tuples to the HDFS side. So this is what it is, right? The metrics that I talked about shows you various numbers here. The latency, the performance, the per second. The current rate is 0 because it has finished processing the whole Kafka topic. So there are no more tuples that are being received from Kafka, and that's why the current one is per second is 0. But these are the various things. Now, I can click on the physical one. It shows me more details of the physical aspects of my pipeline. It shows me the containers, a list view. I can actually see a DAG, which is nothing but the physical DAG, or the physical version of my logical DAG. Now, in this case, there is no partitioning because my Kafka topic is not partitioned, because of which my Kafka input itself, the Kafka input operator itself, is not partitioned. But if I had a partition topic, my Kafka input operator would have been partitioned, and I would have a parallel partition here. Now, this particular application doesn't have that, but let me go back and see if I have any other. Okay, here you can see that This particular example, the mobile example, has a partition operator where the location finder is partitioned, and there are two partitions of this logical operator. Okay. So as you can see, the logical view shows only one, but the physical DAG view shows two, which means the logical finder operator is partitioned into two partitions. Anyway, going back to my Kafka to HDFS filter, I can click on an operator, and going back to, actually I made a mistake. I should be in the logical view. Okay, in the logical view, I click on the operator and I can see the parameters that were passed to that operator. So I passed the parameters to the applications, but the parameters ultimately went to the operator, and the operator knew that it needs to write the output out to TMP webinar 2, and within that, the file to write is default output 1. So let me go back to my Hadoop cluster, and I'm going to see dfs-ls/tmp and /webinar2, and you can see that default output 1 is what I had specified, default output 1. The operator, because it's still, the file is still open, it has given it a temporary name. So this is the file which has the output data, and you can see that the application has successfully copied data from Kafka to HDFS. So let me dump out the data in this file on HDFS, and you can see that of course it has filtered the data, so you'll see fewer tuples here, and all of these tuples have the last column value about 20,000, because that is what the filtering operator has done. So this is, you can see the application has done its job. I can actually go back to my application and kill it. So I'm going to shut it down because it has done its job. And the second part of this demo is taking the same app. So I go to Kafka to HDFS filter app, right? And like I told you before, you can take this app and customize it. So we have the GitHub URL which shows you the source code for this app. So you can go to DataTorrent app templates, and under that, for this particular template, which is under Kafka to HDFS filter, you will see the source code. There is a description and the README file that talks about the template itself, and there is some talk about, if you go to the source folder and go to the application.java, there is some text about how to take this application and modify it. Now what I've done is I have already downloaded this to my computer here. So I'm going to load that workspace in my IDE. So that will show that I have this source code that I can customize and create my customized version of this app. Okay, so I have the Kafka to HDFS filter already present in my workspace. Let me go back to my application.java file here. Now the application.java file, see the code here outside of the comment block is what the template does by default, what we saw. Now what we want to do is add a processing step called transform, right? So what I want to do is the output that we saw here, the middle column, which is a string, I want to lowercase that. So the user part of it will be lowercase in my modified app template. So to do that, I'm going to add a transformation operator, and that is already explained how to do that in this code in the comment block. I'm just going to take that code blob and put it out. And one thing I need to do is the transform operator, also that is schema enabled. So whatever it needs to do, I don't need to write Java code for it, but I can just provide some configuration. And in this case, instead of 2 uppercase, I'm going to say 2 lowercase, right? So this transform operator, once added, has this modified DAG, which which adds the transform step, which lowercases the middle column, right? Now, adding this is not enough. I also need to create a stream that includes this this transformation operator. So I need to replace this particular line with the modification of my DAG, which adds not only the filtered stream but also the transform stream, right? So the Java code modification is complete. It gives me this additional transform step, and like I said before, that particular step will lowercase the middle column. Now, just to demonstrate something, I'm also going to change the application name. You can read up on application annotation, but it creates an application with a name. I'm going to call it, I'm going to add -cust at the end. Same thing, even for my POM, I'm going to change the artifact ID to add cust at the end, and also add in the name cust and cust, just to show that I have customized this app template. And after having done that, I'm going to go to my shell, where I'm going to first of all show that I have modified these 2 files, and I'm going to build this using Maven. I'm going to do skip tests because we don't want to run tests right now. So after doing these modifications, my Maven is going to generate my modified application as an API file with this name, Kafka to HDFS Filter Cust 9.0 APA. This is the file that just got generated. And using my DataTorrent RTS, which is here, I'm going to go to my Develop tab, go to Application Packages. Now, this one shows my imported package already there, but I'm going to upload the one that I just built. I'm going to upload it from my templates workspace, app templates, Kafka to HDFS filter, and target directory. As you can see that just a minute ago, I created this API file. I'm going to upload it. And this application package is going to sit side by side with the previous imported app. And because I have renamed both the package as well as the app inside, it's not going to create a naming conflict, as we'll see, right? So this is about to kind of add some finishing touches before showing up the app in my application package UI. So this is the new package that I just uploaded 11 seconds ago. This one has the application. I modified the application name, added -cust at the end, which shows up here. Now I'm going to be able to run this application. The application name also has -cust at the end. I'm going to use the same set of parameters because it's the same template with some modification. So the input and the output parameters are the same. I'm going to, the topic is transactions. The output directory is also the same, and I'm going to call it cust output 2, right? So under TMP webinar 2, I'm going to create cust output 2. And one more thing I'm going to do is, of course, I need to change latest to earliest because we are going to use the same Kafka broker and the same Kafka topic. And one more thing I'm going to do is I'm going to modify my filter. Instead of 20,000, I'm going to make it 30,000. So I'm going to see fewer tuples, and the tuples will also have the middle column lowercase, right? So I'm going to verify my parameters. Everything looks okay, and I'm going to launch it. It takes a few seconds for it to unpackage the application on the destination side. Jan will unpackage it, find containers, deploy the applications into the containers, and give control. As you can see, the DAG, the modified DAG, has the transform operator. So there are two things that we are going to see, right? On the input side, it is going to read the same number of tuples, almost 1,999,168. The filter operator has even fewer output tuples because I changed my filter condition to include even fewer tuples because the threshold is now higher at 30,000. It's going to output only 83,000 tuples, and the transform operator, which is the additional step, is going to lowercase the middle column, right? The rest of the DAG is the same. On the output side, it is going to write out 83,000 tuples to the directory that I talked about. Going back to my cluster. Okay, so I'm going to look at TMP webinar 2. I can see cust output 2. It has, the size is much smaller. So let's see the contents of this file. As you can see on the output side, the middle column is lowercase, is lowercase user underscore something, and all of these tuples have numbers higher than 30,000 because that is what my filter operator did. So I hope that you have been able to appreciate what the template we have been able to achieve with a template that we that we so easily downloaded from the AppHub. We were able to modify and customize the behavior of the template, and we were able to kind of deploy and run this template in DataTorrent RTS. And the DataTorrent RTS lets you monitor and also visualize the DAG as well as the metrics and events related to running of your template. So that was the demo part of this presentation. Let me see if I have any questions so far. Nothing. So let me go back to my presentation. I have just a couple of more slides. So let me go back into my presentation mode. So what I'm going to talk about now is the roadmap. Now, I've shown you what we've done so far. What is there in DataTorrent's roadmap is to add more templates related to visualization, such as that allow you to create widgets and allow you to visualize metrics such as size of data moved, lines per file, number of errors, and things like that. It also lets you visualize custom defined metrics such as KPIs, be any amounts or data in your operator that you want to visualize using the visualization widget. that I briefly showed you. So we are kind of doing more work in that area as part of our roadmap. I also talked about cloud integration. One big part of that is AWS ecosystem templates. So templates that not only run in AWS EMR, but also work with Kinesis, AWS Kinesis, which is the message broker, Amazon message broker, similar to Kafka. And then S3, which is the Amazon version of HDFS, and Redshift, which is the data warehouse. So, so those are the templates, or more templates like that are coming. We are also working on other kinds of app templates like FTP to HDFS, or Kafka to Elasticsearch and Cassandra, and other templates that involve some processing or analysis steps, like from going from Kafka to HDFS, going through the filter and transform steps that I actually demonstrated. A bunch of resources. So obviously, there are we have done a lot of webinars and presentations like this. So these resources are mentioned in the slide. Obviously, this presentation will also be made available on YouTube. You can go to our YouTube channel, and also the slideshare.net site for this presentation, right? The link to the AppHub is here, and of course, you can also join various forums on social media platforms such as Twitter and all that stuff. So we are also hiring. So you can go to our website and look at the jobs page to see what kind of positions are available, and and if you're interested, you can join us. Let me see if there are any questions. It looks like okay. I don't see any questions so far. So looks like we are good to go. I'll give you maybe another minute or two in case you have questions. Please post them in the questions tab in your GoToWebinar client, and I'll see them. Okay, so looks like we are good to go. Thank you, everyone. Again, thanks for attending this webinar. I hope it was very useful, and we always welcome feedback. So feel free to send us feedback. Using the links that were made available to you. Thanks, everyone.